everyone, and welcome to the final lesson of this tutorial. In this video, we're going to create some shaders for our elements, as well as go over some basic lighting and rendering. So let's get started. To start off, in our main sim geo node where we've been working, I'm going to put down another null just so it's easier to render the glass object. So I'll just put down a null, put it after the transform we did, and I'll call it out glass. And then what we're going to do is we're going to go up to the object level, and we're going to want to create a geometry node for each element. That way we can control which ones are currently rendering, as well as assign shaders to each element. So I'm just going to quickly do that. Just put down geometry, and this one will be our liquid. And I'm going to just turn the display flag off just so I'm not loading all of them at once when I don't need to. And then over on the render tab, I'm going to go ahead and go into the sampling and enable velocity blur. This won't automatically enable velocity blur in our render. We have to do that on our render node. But enabling this now just means we don't have to come back later to make sure that it's turned on each geometry object. So now if we hop inside this object, we can just put down an object merge. We can go ahead and grab our liquid. So if we scroll down, we see our out liquid surface we made, and there's our liquid surface. And then we're just going to do this for each element that we've made. So we'll just go back up, make a copy of this. This one will be our glass. And we'll grab our out glass. Then we can grab our foam big bubbles, bubbles, and merge that in, so out big foam. Then we can get our foam little bubbles, grab that, so we grab those points. Then we want to grab our air bubbles, which are those rising bubbles as well as our stuck bubbles. So I'm just going to actually merge those both in here. So let's grab our rising bubbles as well as our stuck bubbles. And we can go ahead and merge those together. So now we have both of the bubbles. And then lastly, we just need to bring in our fizz. Get rid of this extra node and grab our fizz. So now we have each element in their own geometry node. So I'm just going to turn on our glass to start with just so we have something to look at in our scene. And before we start rendering, we also need to bring some lights into our scene, otherwise it'll just render with a default headlight shining down onto our glass object. So I'm going to create a pretty basic lighting setup. So I'm just going to click up on the shelf tools on the skylight. So it'll automatically create a distant light and an environment light for us, acting as the sun and the sky respectively. And on the skylight object, you can adjust the angle of the sun as needed. If you want it a little bit higher, lower, move it around the scene. I'm going to rotate mine around some, just to have a little bit of a direct light on the side of the glass. And then one more thing you might want to change is on our skylight, you can see that it's created a gradient that's kind of mimicking a general sky look. So that we have this green down at the bottom that would be like the ground and the blue for the sky. And that might be fine for some setups, but for something like our champagne where we have a lot of elements that are going to be refracting and reflecting, we definitely want something more interesting for them to reflect. So we're going to uncheck Enable Sky Environment Map so we can bring in our own image. There are a lot of places you can grab different images to be used for environment lighting. I'm just grabbing this image off of HDRI Haven. They have a pretty expansive gallery with a lot of free images for you to use for environment lighting. And I just grabbed this out of their indoor collection. I'm just going to select our environment map and bring it into our scene. So now you can see we have a little bit more interesting color variation going on in our environment light as opposed to a simple gradient. Now that we have this basic setup done, we can go ahead and create a render node. So I'm just going to go up to Render, Create Render Node, Mantra PBR. And this will take us to our out context, and it just automatically creates a mantra ROP for us, as well as set it to physically based rendering since I specifically selected mantra PBR. And right off the bat, much like the file cache nodes, I have a specific naming convention I like to use for renders, so I'm just going to go ahead and change that now so that we don't forget to do it later. I don't like depending on the hip name of our current file, so instead I'm just going to change this to $OS, and then $OS, and then the frame number. So that way we have render, and then the directory named by our ROP node, and then our ROP node, and then the current frame. So I'll just name our ROP node Champagne V01. In case I ever need to version up, I can quickly do that here just in the name. Then we want to make sure that the correct camera is selected. So you can see we have our camera here. And I'm going to override the camera resolution so that it's not rendering at full resolution. This way it'll iterate quicker as we're making changes. I'm going to change this to 2/3 resolution. I'm also going to go over to Objects and uncheck Headlight Creation. Since we created our own lights, in theory it should not be creating a headlight, but just to be safe I like to turn this off just to ensure that we're not getting any default lights created in our scene. And with all that set up, we can go over to our render view. We have our render node selected, and we can just hit render. So you can see that everything's working as expected. Right now we haven't created our material, so this is just a default flat material on our glass object. You can see we have lights in our scene and that everything is rendering as we would expect. So I'm just going to stop the render, and we can start working with the materials for our objects. So to do that, I'm going to go over to the matte context, and then you'll see that there are some shaders already here. These were created when we used the shelf tool to emit fluid from our object into our glass. The shelf tool also created these basic shaders for fluid rendering, but we're going to create our own shaders so we can go ahead and get rid of these. And then I'm just going to create a principled shader, and this is going to be our glass shader. I'm just going to rename it glass, and then I'm going to go back to our object network. On our glass object, I'm going to assign the material we just created. So assign it glass, and then if we go to our render view, and we hit render, you can see that it's picking up a new shader, so it's picking up the shader we created. Now I'm just going to start tweaking different values so that it looks more like glass. These are all values that I've figured out beforehand. These are just what worked best for my final output. I'm going to turn down the index of refraction to 1.3. I'm going to turn the roughness all the way down so that it's nice and smooth. Then we'll scroll down, and on our transparency, since it's glass, we want this at 1. So that it's fully transparent, and you can see this is where having an environment map comes into play. This is a lot more interesting than a basic gradient. And then if we scroll back up over on opacity, I'm going to enable fake caustics, as well as turn up the shadow opacity. Enabling fake caustics basically helps the renderer create transparent shadows without having to increase the light sampling and therefore increasing your render time. Now you might notice on our render, we're getting some strange little jagged shapes, and if you zoom in, you can also kind of see striation from the polygons of the glass. And that's because our glass is relatively low poly, so we're going to have to subdivide it at render time to help smooth that out. So we go over to our object, I'm just going to stop the render, and then I'm going to check on render polygons as subdivision, and I'm going to increase the subdivision quality to 2. And rather than sharpen all boundaries, I'm going to smooth everywhere to help smooth out those jagged shapes we're getting. So now if we render again, you can see we've gotten rid of those really jagged shapes and the general striation along our glass. The next shader I want to work on is the shader for our liquid object. So I'm going to go to our matte context, and then rather than just put down a basic shader, I'm going to put down a material builder. And I'm doing this because I'm going to tweak parts of our shader using surface values of our geometry. So I'll go ahead and rename this to liquid. And I'll make sure to assign it to our liquid object. So material, liquid. We can hop back to our liquid material. We can jump on in. So right off the bat, I'm just going to get rid of these global variables since we don't need them for what we're doing. going to put down another principled shader. And I'm also going to put down a compute lighting. And we'll just hook in our shader to our lighting, and then our lighting into our surface output. So let's go turn on our objects, and then we can hit render to see what we're working with. So back to our material. And then much like our glass object, we're going to turn our transparency up all the way since it's a see-through liquid. And then I'm going to change the transmittance color. This is basically going to give a little bit of color to our champagne so it doesn't just look like water. So we just want to get something that's not too saturated, just kind of brings a little bit of color into our liquid. And if you don't want your whole viewport to render every time you make a change, you can hold Shift and left click and drag a box, and that'll just render inside that box. Now with our color selected, I'm going to go down to our refraction index, and I'm actually going to turn this way down. Now physically you would expect something like water to have an index of refraction of around 1.3, but I'm going to turn this down, and it's not going to be physically accurate, but it's going to be what looks best. The great thing about working in CG is that sometimes you get to break physics just because it looks better. So I'm going to turn this down to 0.87, and then I'm also going to turn the roughness down to 0. And then I'm going to unselect shade both sides as front. And then again on the opacity, I'm going to enable fake caustics. And turn off the shadow opacity. Now you've probably noticed as I've been changing these values and as this render has come out, we're getting some kind of weird intersecting shapes. If you zoom in, you can see this kind of weird intersecting geometry happening along our glass. You can see just some weird disparities going on between our two objects. And the reason for that is even though we booleaned our liquid and tried to make it as flush to our glass as possible, it's still not quite perfect. It's still not quite matching up. So we're going to make some quick tweaks to our liquid surface. Just going to stop our render. We're going to go over to our object, and then we're just going to go to our geometry for our liquid. And then switch over to this view so we can see what we're looking at. You can see that we have a little bit of space between the liquid and the glass, and that's what's causing the issue. So I'm going to peak our liquid out a little bit, a really small amount, so say 0.0005. So we have a little bit of stretch outwards, and you can see that that created a little bit of an issue along these seams here. These are the seams that were created originally with our boolean. So to fix that, we're going to put down a group node, and we're going to change it to edges, disable base group, include by edges, and select unshared edges. This way we can just see those edges that are kind of breaking from that peak. And then we're going to put down a group promote. This way we can promote our edge group to a point group. So we're going to grab our group that we just created. So we're going to take our edge group and convert it to a point group. And now that that is a point group, we can put down a fuse. And we can set it to that point group. And then again, the snap value might need to be tweaked a little bit just to make sure that we're grabbing all of those issue areas. So I'm just going to increase it a little bit. So now we've sealed up those little edges. So now if we go back to our render view, you can go ahead and save this snapshot so we can see what it looked like before. So now you can see we've gotten rid of the weird little jagged detail we were getting. Now you might remember me saying we were going to use the vorticity attribute from our liquid on our shader. And since we're in our liquid object right now, we can go ahead and take a look at that attribute. So with this bottom node selected, I'm going to go over to our geometry spreadsheet. and you can see we have our vorticity attribute. I'm just going to click it so we can see the highest value. And if we scrub through our timeline, you can see that the value changes pretty drastically. It goes from 0 all the way up to a number close to 500. Then it kind of scales back down as the liquid calms down. So we're going to want to keep these values in mind. So I'm just going to go to a frame where the vorticity is particularly strong so that we can get a sense of what it's doing in our shader when we plug it in. I'm just rendering out that image. So we'll go back to our shader, to our liquid, and then I'm going to snapshot our current image. I'm going to pause the render, and then in our liquid material, I'm going to put down a bind, and this is going to let us grab the vorticity attribute from our geometry. So we'll just write vorticity here, so that's the attribute it's grabbing. And I'm going to use this attribute to drive the roughness of our refraction. Now the roughness is usually a value between 0 and 1, and as you might remember, our value is between 0 and 500. So I'm going to put down a fit. That way we can go ahead and change the range of our vorticity attribute. So the source minimum will still be 0, and let's put the maximum at around 475. So now we can go ahead and plug this into the roughness. Just plug it in. So now you can see that the roughness is taking in this input. So let's go ahead and see what this looks like at default. So if we flip between the two images from before we plugged in our vorticity to after, you can see that there's a pretty big difference in the clarity of our liquid. You can see that it seems a lot rougher, almost kind of frosty in some areas. And this is a little too strong since this fit is setting it from 0 to 1, so we are getting areas of full roughness in our liquid, and we don't really need that. So I'm going to change our destination min and our destination max. I'm going to change our min to 0.1 so that we always have a little bit of roughness. It's not 100% clear. Then our max, I'm just going to make 0.3. That way it's a little bit rougher, but it doesn't look like a frosted glass. It's just a little bit swirly, creating an almost volumetric looking effect. And now with our liquid shader pretty much done, we can go ahead and start working with our large foam bubbles. I'm just going to stop the render, go back to our object context, let's turn on our big bubbles, and then we'll go into our matte. And then our big bubbles are actually going to be a pretty simple shader, so I'm going to put down a classic shader. And I'm going to name it Big Foam Bubbles. Let's go ahead and assign it to our object. Now let's go back to the shader itself. And let's scrub to a frame where we can see some more of our big foam bubbles. So you can see them popping up towards the top. Let's go ahead and render that. Hop back to our matte context. So you can see we're definitely picking up something here, and the classic shader defaults at a darker color, which is why these are coming in so dark. So for our big foam bubbles, we're just going to disable the diffuse altogether. On the reflection, we're going to turn down their roughness so that they're perfectly smooth. And then we're going to enable coat reflections, as well as enable refractions. And the main reason that I'm using this classic shader rather than the principled shader is so that I can check on thin film refraction. Checking this on makes it so that bubbles refract as if they are a thin filmed object rather than a solid marble. And then I also want to give them a little bit of transmittance color as well so that they don't have a perfectly clear look. So we'll just give it something a little bit pale yellow, kind of matching our champagne. Now that we've added a material for our larger foam bubbles, we can go ahead and do the same for our smaller bubbles. So let's go back to our object, enable our little bubbles, and our matte network. Our small foam bubbles are also going to have the roughness driven by the vorticity, so I'm just going to make a copy of the liquid shader we've already created. I'll just rename it to Lil Foam Bubbles and assign it to our geometry. Now while we are going to be using the vorticity on our foam bubbles like we did with our liquid, we're not going to use the principled shader that I used for our liquid. Much like our large foam bubbles, I want to use a classic shader so that I can take advantage of the thin film refraction. So I'm going to remove this, put down a classic shader. Then if we check the little arrow next to surface to unspool it, you can see we have a lot of inputs and we want to plug this into the refraction roughness. So we're going to have to scroll down and find it to plug it in. So down here, refraction roughness. Now that we've plugged in our vorticity into our refraction roughness, we can go ahead and connect our shader to our lighting. And let's go ahead and start rendering so we can see things as we change them. So I'm just going to render this little area here. And again, these aren't transparent yet, which is why they're coming in black. So we're going to disable the diffuse on their reflection. We're going to smooth them out, so turn down the roughness. We're going to enable coat reflections. However, you might notice once we've enabled coat reflections, we're getting some kind of bright highlights on our coat reflections. So I want to actually turn down the intensity of the coat, as well as increase the roughness so it disperses light a little bit more. And then on refraction, we're going to enable refractions and change them to thin film refractions. So you can see we're getting more of a foamy look to our small bubbles. And I'm also going to change the transmittance color to match our larger color. So we'll just go up and grab this value and paste the value here. So now they'll match the color of our larger foam bubbles. And then one more thing I want to tweak is down on our vorticity attribute where we fit the value in between 0.1 to 0.3. I actually want to increase this a little bit because I would expect the foam to disperse light a lot more than the liquid would. So I'm actually going to increase our roughness values. So I'm going to change this to 0.35, this to say around 0.65. So it's kind of noisy right now. We're probably going to have to up our samples soon. But as it renders out, you can start to see we're getting a lot more dispersion of the light throughout the foam. Alright, next we can tackle our liquid air bubbles. So let's go to our objects and turn those on. Let's go to our scene view. And I'm going to scrub towards the end where we'll be able to see more of the bubbles as the foam has risen to the top. So we'll go to our matte. And the air bubbles are going to have a pretty similar shader to our liquid. So once again, I'm just going to copy our liquid shader. And I'll just rename this air bubbles. Then back on our air bubbles object, just assign the shader. Hop on in. And we can go ahead and delete this bind and fit because our bubbles don't have a vorticity attribute. So we don't have any sort of attribute to be pulling in and assigning to our roughness. So we can just delete those. So let's go ahead and see what we're working with here. Since we're getting a lot of noise with our foam dispersion, I'm actually going to turn off the foam for right now while we're changing the shader for our bubbles. So just go over to our object, and for right now I'm just going to turn off the display on our foam. Go ahead and render that. Go back to our material. Go ahead and isolate where we can see some bubbles. And again, these are just values I found while tweaking to get the result I liked best. So we can go ahead and leave the transparency and the color as is, and I'm going to turn down the reflectivity a little bit so they're not quite as mirror-like. And I'm going to increase the reflection tint. And I'm going to decrease the index of refraction a little bit more. So say 0.63. And I'm actually going to turn the roughness up just a smidge, just so they have a little bit of cloudiness to them, but not too much. And I'm going to change the coat intensity to 1, so this basically is giving them a reflect coat. And then I'm going to recheck shade both sides as front. And lastly, over on the opacity tab, I'm going to change the shadow contour and the shadow opacity to 0.5. So now you can see we have some nice little air bubbles inside of our liquid. Go ahead and stop that. Then the last shader we need to make is our fizz. So let's go back to our object and turn on our fizz. Then in our material context, our fizz is also going to be a pretty basic shader, so I'm just going to put down a classic shader and rename it fizz. Go back to our object and assign it. And let's make sure we're somewhere where we can see a decent amount of fizz. Yeah, there should be plenty on this frame. So let's go back to render view. And let's just isolate that area where we saw fizz. So you can see we're having our little dots come in, our little points of fizz. So let's go to the material and tweak it. Much like our foam bubbles, we're going to disable diffuse. Smooth out their reflections. And then we're going to go over to the refract, enable refractions, thin film refraction. And we'll give them a little bit of roughness so that they're dispersing light. And then that's pretty much good to go for our fizz. It's a pretty small element, so it doesn't need too many tweaks or an additional color or anything. Let's go ahead and render a frame with everything turned on, see how it's looking. Alright, so all our elements are looking pretty good, and you might remember we turned on the velocity blur for our geometry elements, but we haven't turned it on for our render. So let's go ahead and do that now. So our out context on our ROP node, go over to rendering, and we'll check on allow motion blur. And I'm just going to isolate a little area, because this is going to increase our render time a decent amount. So as this starts to come into focus, you'll see we're getting little bits of our particles of our fluid coming outside of our glass. And if I isolate a different area, you can see it's pretty bad down here on this side of the glass. You can see we're getting a lot of the motion blur is making it look like the fluid's coming outside of the glass. All this means that our velocity value is a little too high, and it's causing the blur to make it appear as if it's coming outside of the glass. So we can just tweak our velocity values on our geometry. Let's go to our geometry, to our liquid. And we can just put down a point wrangle. We can just set at v times equals channel, we'll call molt. And create the channel. And the value I found looked best for my situation was 0.3. So having everything be about a third of the velocity that was coming in. So I'm just going to go ahead and copy this node, paste it on all of our other objects with velocity. So now all of our objects are at a third of velocity, and if I go ahead and render this little area again, you can see that we fixed our velocity issue where it made it look like the objects were coming outside of the glass. And again, right now our render is pretty noisy, so we're going to have to render at full resolution and start increasing our samples. So go ahead and stop our render, go over to our out, our ROP node, deselect override resolution, and the resolution of your camera, in case you weren't sure what it might be, if you go to your camera itself, on the View tab, you can see the current resolution is set at. At default, Houdini's cameras are set to 720p. You can change it to some other default values or put in whatever value you might need. For now, I'm just going to leave this at 720p. Let's go back to our out context, our ROP, and I'm just going to increase our minimum samples from 1 to 4, our max from 9 to 16. I'm also going to increase our stochastic samples, so this will help with transparency. I'll increase it from 4 to 8. Then I'm just going to increase our pixel samples from 3 to, let's say, 5. Let's go ahead and see how that looks. And while that renders, we'll go over some of the things we could do in the Images tab. Go over to Images, and I just want to quickly go over some of your options that you have when rendering. One thing to keep in mind is since we're rendering so many objects with refraction, the render time for this is going to be pretty high, so you might want to break it out into separate render nodes. And you could do that using image planes or separating by objects or a combination of both. In your Extra Image Planes tab, you can export some pretty standard output of the different lighting AOVs or the depth, and use those AOVs in comp to really plus up your render. And again, over in objects, you can force specific objects and have the other objects set to phantom. For example, you could force the liquid and set all the other objects to phantom. So you would still get their reflections and their refractions inside of your liquid. So that's one option for rendering this animation if you choose to break it out by object. Or you can just go ahead and render everything as is, as I am right now. And then whatever setup you choose to render with, whether separating out or rendering everything at once or working with image planes, once you're happy with the overall look of your render, you can go ahead and render to disk to go ahead and start rendering. I went ahead and rendered my image at a high resolution up to 1080p. So let's take a look at our rendered animation. So now you can see we have a nice overall simulation of champagne being poured into a glass, rising up in the glass, made up of several different overlapping elements, from the little air bubbles to the different kinds of foam bubbles and fizz emitting from the top of our glass. Thanks so much for following along and watching this tutorial. I hope I was able to help you gain a deeper understanding of Houdini's flip solver, particle solvers, and working with those simulated points. There are all kinds of projects you could tackle using these techniques. I hope you enjoyed this tutorial. See you next time.